Hi everybody, it's Kyle Cordes again. This is my third video about cycle, the sort of some hows and whys and other thoughts. Again, I am Kyle Cordes at Oasis Digital. I mostly work on and teach Angular, but I also spend some time on some non-Angular topics. So let's get oriented to where we were. I am walking through some code in this example project, and I'll leave the URL up here in a moment if anybody wants to pull this code down and run it. It's pretty easy to run it. I have a command window or a terminal window. I just ran npm start so that the whole thing runs and it auto reloads and all those good things. And then I have the code open over in Visual Studio Code, and I can look at the running code here. Let me see here. So what I've been through so far is this kind of home screen, these chips, which are static components with parameters, and then this grayscale adjuster thing. What I'm going to do next is a GitHub search. Going to take a look at that. Now, this GitHub search code, the important thing about this, this came from a published example. I think it might even be one of the official published examples of things you can do with cycle, kind of showing you how to use HTTP. I'm not sure exactly where the starting point came from, but I've reworked it very substantially. It bears fairly little resemblance, but I thought by staying in that familiar topic area, I could get the attention in my presentation here on some of the more sophisticated nuances. So here we go. As always, a cycle component is just a function that takes a set of sources, returns a set of sinks, of which the contents are mostly observables or things that can give you observables. But I'm kind of turning up the complexity and abstraction with this example. So let's see how the example runs. Like, for example, I could search for the word cat, and I'm going to find all the cats on GitHub, but I could limit myself to things that are tagged with the Java language and get a shorter list, and I could limit myself further to things that have 100 stars and get a shorter list. You can see how long that list is. And interestingly, I think this means cats are more popular than dogs, maybe, or maybe it just means the word cat appears a lot in computer things. Anyway, then these are just links to the GitHub pages for these, and these don't matter. The topic here doesn't really matter. This is all about the code of how it works. Some important things that might not be obvious. If I type 2 letters real fast, I only get one search. Well, I guess it didn't matter. I only get one search. It doesn't redo the search for every keystroke, so there's some debouncing happening in there. It only does a search if this first one has something in it. It never searches if there's nothing in the first, in this description search. But these other two are optional, and this one is text, this one is numeric. Okay, so let's look at the code it took to make this happen. So again, the code's not terribly long. I still find cycle to be really quite nicely concise. Here I am at under 100 lines, and I think I've programmed this pretty idiomatically. Starting at the beginning, as always, cycle is built heavily on streams. So first we need xstream, that cycle-specific or cycle-oriented stream implementation. We emit virtual DOM, so I need to import the vocabulary. I need to talk to that. And this thing is now using HTTP and time. Now there's a lot going on behind the scenes of both of these. We're going to try to spend as little attention as possible on that behind the scenes and try to focus on just the experience of this application development. Okay, so this thing is only one component. I've implemented this whole rectangle, roughly like I'm gesturing here, as a single component. I've found it easiest to look at the view first, so I think I'm going to explain this thing starting with the view and then go back to the other code. It's not quite model view controller. The thing's not quite a controller, but it's pretty close to that. And the view is usually the easiest part to understand from. Okay, so this overall section is divided into a big wide grid column and a narrow grid column. I'm using pure CSS, and so pure G is sort of the equivalent of a bootstrap row, and this is the equivalent of a bootstrap 2/3 column, and here's a 1/3 column. My 1/3 column only has a P in it, just a single paragraph, so everything interesting is in my main column, so everything interesting is in through here. As always with this snapDOM virtual DOM approach, it auto-indents. It looks structurally a lot like HTML, but it is just TypeScript. It is somewhat typed, unfortunately, and all the children of an element live inside an array as the final parameter of the element. So the div, this is how you do containment, and so between each child of the element there's a comma. So this really is just JavaScript or TypeScript, even though it doesn't quite look like it. Okay, so we label our search with an H2, and then we have a form. I believe the only reason I did a form here was I wanted to have the right formatting from my pure CSS library, and it did useful things when it had a form specifically. So I didn't technically have to put a form around these elements, but this helped it format a little better. There are times when it really does matter that you make an explicit HTML form, but this is not one of them. Let's take a look here. I'm going to gloss over this briefly. Down here, this is where we display the output after this HR. And so this is just a UL with some LIs in it. So here's the first really interesting thing we've seen in, I guess, the third video now to reach this point. Here we are iterating. Now, I think the single greatest point about this approach, about this virtual DOM approach, compared to the sort of template approach you see in Angular and Vue and a bunch of others, the single biggest benefit is that to do iteration, I didn't pick up a tool specific to this library for iteration. I don't have a template language with its own invention of how to do iteration. I don't have anything specific even to the web for iteration. To do iteration, I simply did a JavaScript iteration. I chose to use map because I wanted the output. I could have used a for loop if I wanted to. There was not a need to invent an application-specific or domain-specific way to do a common built-in operation because I could just use the built-in way to do the built-in operation. Now you can tell by the fact that I could map over it, this thing is actually, here I'll go ahead and I'll type this. Oops. So results is actually an array, and I don't think I've typed what's inside it, but by making it explicit that this is an array, it's more obvious that I'm doing an array map here. This didn't change the meaning of the code, it just made it a little bit more clear. Then inside this I have a single search result. So this means give me a UL, so an HTML UL, and then the final parameter of that UL is supposed to be an array. And to get that array of things that I put inside the UL, I'm going to take each of my search results and use an ordinary JavaScript map to get an LI. So this expression will return an array of LI, and then those become the children of the UL. So I'm building up the right HTML structure using built-in JavaScript, TypeScript operations. Everything else from here is the same as we've seen in previous videos. So if you haven't watched our previous videos, go back and take a look. Now up here above, I've done something I think more interesting, more powerful. Label field, that's not a built-in HTML thing, and if you look, that's not a thing that I'm importing from CycleDOM. This is the second most powerful thing that's really compelling about the virtual DOM approach. Now, I'm glossing over, there are some compelling advantages to the domain-specific template approach around performance. I'm going to ignore all those and talk just the advantage of Cycle's virtual DOM approach, shared with React and many others, is that I can just write a function here that abstracts some set of HTML. So if I wanted to do a certain repeated pattern of HTML, I could simply write a minimal function right here. So I didn't need to go create another component. I didn't need to put it in another file. I didn't need to register it with with my library or framework in any way. I didn't need special IDE support for it. I could just make up my own sort of a meta element or combined aggregate element, composed element, give it a name, make it a function, and call it where I need it. So here's a div with several label fields. And what is a label field? Well, a label field, that's just a div with a label and an input inside it. So instead of repeating this structure 3 times, I could make a function. Because it is so very easy to make a function and use it with this virtual DOM approach, I think that it's much easier to sort of follow the rule of dry, don't repeat yourself, however you want to say it. It's much easier to avoid repeating yourself if you can just use the built-in capabilities of the language instead of having to use a feature of a library or framework to do so. Okay, so I think I've now talked in some depth about everything going on in the view. I think the only important thing to remember is that this thing here is an ID. And this ID is both used as the label for, and it's used as the ID of the input. And that'll become important when we go consume these elsewhere in the code. So the only thing to really know about this view is that it has a search, language, and stars inside it. So let's go up and take a look at the controller, I guess we'll call it for lack of a better word. Let me get my scroll to the right place. Save some space. I have to remember when I'm recording these that if I move my mouse over here right now, you can't see it because my face is superimposed over the way. So I don't want to put any important code in that part of the screen. Okay, so first I built up a little bitty function here, just right in line inside my other function, because that's a legit easy thing to do. I wanted a stream of the values inside an input field. So I wanted an easy way to get a stream that right now it has the value dog, and now it has the value, pet or whatever. So that I wanted to get that in stream form, because as usual in Cycle, the answer to everything of how you do it is using an observable stream. So I need to convert from one to the other. Well, the low-level API to do that is you take this DOM that arrived as part of your sources, and you call select with some CSS-like selector. Excuse me. You call events on it and tell it what kind of HTML DOM event you want. And then at this point, you have an observable stream, and you can then transform it however you like. Here's how I've chosen to transform it with this reusable chunk. I've said, whenever an input event happens on whatever element I've selected, take that thing, and this is just a bit of ugliness to be able to call this cleanly in TypeScript, but take that thing and dig out its target and get the value off of it. So the target will actually be this HTML element. So the value, that means in this case, the value of an HTML input element is just the text that's in the input. So at this point, I have the text, but I really wanted to always get that initial empty text, because this input event is only fired when the text changes, and I want to have the initial value. It can come in very handy to have that. So I said I want to explicitly start with the empty string. So if I call my val$ function with any CSS selector, it'll go find an input like that on the screen and give me an observable stream of the values inside that input. So to do my search request, I did that for search, language, and stars. So that's simply these three things. So I take search, language, and stars. Now each of those is an independent individual observable stream, and what I really want is a single stream of the entire search parameters. So there's conveniently a combine function, and this would be called combine latest if you're using RxJS. So I can say combine those three streams. So at this point in the code, at the end of this line 24, I have a single observable stream. Okay, right there, single observable stream. Now, I'm pretty sure I only ever want to do anything if you've typed at least something in here. So the next thing I do with that stream is I filter it to only include things where something has a length greater than 0. Now what is that something? Well, this set of values you pass to combine, or the set of streams you pass to combine, you'll be converting that sort of array of streams to a stream of arrays. And so the values that flow through the observable chain here will be arrays. So this query is actually an array. And in fact, you can see right in here that the code was able to, the VS Code was able to reason about the type and tell me that's an array of 3 strings. And the 0th one is the one I care about. And so that corresponds to this one right here. And so I only want to pass things on down through this chain when there's something in the search field. Now, I mentioned that this is debounced. Like if I just type a few letters real fast, it doesn't search every time. It waits till I've stopped typing. That's called debouncing. With Xstream, the way that you kind of reach for and use the more esoteric operators, so things beyond the built-in couple dozen operators, is you use this compose mechanism. So compose is an Xstream mechanism that says, go take this other thing and apply it to my stream. So go get something and apply it to my stream. And I'm going to mostly gloss over this because it's much harder to explain than the equivalent is in RxJS. So. But just trust me, this debounces the stream. You'll only get values when the incoming value has been stable for 500 milliseconds. Okay, next, an array of 3 strings is not the right API to send to GitHub to do a search. So this next block of code, this is all about the GitHub API. The details don't matter a lot, but roughly speaking, I take an array of just that search, and then I look to see if the other parts of the search are being used, and if so, I add something to that array following this syntax that I read about on the GitHub API documentation. So there's a specific way that you format a search term in GitHub to do a minimum number of stars, and I've simply encoded that here. Then at this point I have an array of between 1 and 3 things. I put a space between them, and then so this returns a string. And the way you call that API is you pass it a query string with a parameter called q containing your desired query. And so this observable now returns a stream of those objects that are ready to hand to the GitHub API. Next, I wrap them up in an object, which is, you could sort of think of this as a request specification. So this is like a recipe of how to perform an HTTP request. So you need a URL, and then query is simply going to be this value. So a URL, a query, that's the stuff that's going to get automatically appended at the end in a mechanical, reliable way that does all the right escaping. And then this category idea, this actually comes directly from cycle HTTP. So this is not an HTTP concept, it's a cycle concept. It has to do with there kind of fundamentally being one channel that all the HTTP requests and responses are going through in the world of the cycle HTTP driver. And you put a category marker on each request so that the response can be routed to your same code. And we'll see that just a few lines down. So this category, this is just literally the string GitHub. By the way, there's a syntax here that a few viewers might not be familiar with yet. If I just say query, that's equivalent to saying query : query, and so on. So it's a nice little shorthand. Finally, this debug, this is a feature of Xstream. If you say debug, it'll print something to the console, and it'll have a kind of a tag, a marker on there. So if I bring up the console log, which I might, then you'll see these criteria things scrolling by. Now you'll wonder, where did I actually call the HTTP? And the answer is I didn't. In Cycle, your components should never directly perform side effects. The way you perform side effects is by getting the information about what should happen off to a thing called the cycle driver, in this case the cycle HTTP driver. And you're never going to guess how you communicate with that driver, right? So the way you communicate with the driver is via an observable stream, because that's the answer to almost every question in Cycle. So if a component wants to ask the HTTP driver to do some HTTP access on its behalf, it simply returns here in the sinks, they call them, you return an observable stream named HTTP, and that observable stream is going to return a series of these specification objects that ask the HTTP driver to go do something. Then when the HTTP driver does that and gets a result back, it doesn't know what to do with it. It's going to give you an HTTP source. So here you see this type. So there's going to be an incoming source, and that same HTTP information makes it back into our component, and it lands right here. So I'm saying, look at the HTTP source, perform a select. Select means give me just some of what's there, and I want to get some of what's there according to the same category marker that I used. So it's the category thing seems a little odd at first, but practically speaking, it's kind of trivial to use. You just make up a token and use the same token. The flatten thing, this is an odd one. We don't quite have a thing called flat map in here. You actually have to flatten yourself. But roughly speaking, this means the things that this gives me back are actually themselves observable. So this is a stream of streams, and flatten is a way of saying I just want a stream instead of a stream of streams. And I don't want to go into a full explanation of how observable streams work, but there's a lot of great stuff online. If you there's probably a lot more about RxJS than there is about Xstream, probably by 2 or 3 orders of magnitude. But if you learn about observable streams from the RxJS point of view, you'll be able to easily use Xstream if you feel like it. Flatten is no big deal. Next, res.body is a JavaScript object representation of the data that was in the response. And I just happen to know that inside there's a field called items that has an array of my responses. And so this just digs out the specific piece I want. And then start with empty bracket means make sure there's something at the beginning. So make sure I start with something instead of nothing. So what do I do with these search results? Well, I want to display these on the screen, and those simply flow into that view code we already looked at. So this is an interesting bit of learning that happens when you're first using Cycle. if you have something that does not immediately return. So if you have an observable stream that doesn't have any value until later when something happens. So this search result is now going to have no values arrive at all. The challenge is that my search screen is now completely empty, and I don't think we even get much help. Yeah, I'm getting an alert about a missing semicolon, but basically my program looks like it's completely dead, and I don't have any error messages. And that's a little frustrating until you try to understand why. The reason why is that search request is an observable stream, and no data will come out until a response comes from the server. Well, we're handing that to our view function. Well, in our view function, we're taking that search result and we're mapping it, right? So that means that whenever search results emits a value, the view will emit a value. That means that until the first response comes back, I will have no view. And if you have no view, that's what you have, an empty screen. So that's why in these cases you need to explicitly start with saying, well, first we're going to render the empty list, and then now the whole thing renders again, and then as things change, we'll render updated lists. So this is my attempt at a pretty thorough explanation. I don't think I've skipped any code that matters here. See if any other observations along the way. I guess the thing that comes to mind most is what I already mentioned, how great it is to just immediately use JavaScript or TypeScript language features to do decomposition and abstraction and composition. That's fantastic. And then secondly, once you get used to it, this notion that absolutely everything is an observable stream, it's a lot easier to work with than it first seems. I've worked with observable streams very extensively in the Angular context with RxJS, so I found it was just a small amount of adapting to get used to using them for literally everything here. I would expect developers who have had only moderate to experience. So I'd say developers that have anything less than extensive experience with observable streams are probably going to be in for at least some weeks of learning curve to get very comfortable with their pervasive use like we see in Cycle. So I think I'll call that enough for now. We'll probably return to the next video to talk about the next feature. And thank you for watching. I ask you to please click that subscribe button down on the bottom and keep an eye out for my next video. Bye-bye.